Hello, everyone. I'm very grateful to you that you are listening to my session. My name is Andrei Baradin. This year, unfortunately, I couldn't attend PGCon in person. I'm very sorry for this. And many thanks for PGCon organizers, the Langil, and many thanks to Chris Travers, who helped me to do a virtual talk. I really hope that next year we will see in person, and that will be great. Today I'm going to give a talk about indexing technology, which is called GiST, or Generalized Index Search Trees, and new features of GiST and features that I'm waiting for to be committed or even to be developed in GiST. When I was doing this presentation, I found out that it's mostly focused around ideas of some persons. And it happens that way that the presentation is about open source hackers. There are many hackers and contributors who maybe I forgot somewhere here. I'm sorry for this, but I tried to mention as many people as I could in these presentations, and some with photos. Also, if you'd like to download slides with links, it's available on this QR code. It will be here for around 3 or 4 slides. So, how did the GiST started? As many cool technologies started with a paper. Generalization of indexes was proposed by Hellerstein and colleagues back in 90s with a research paper. And the idea was that we have a lot of very different indexes that share the idea of splitting something, like splitting big key space into smaller parts of a key space. So the B trees were kind of GiST, R trees were kind of GiST, and RD trees, and many other variants of tree-like indexes were generalized in this idea of tree generalization. It was further moved ahead by Marcel Karnacker, who gave this technology ability to recover from crashes, thus making it possible to implement in real database like Postgres. And here is a beautiful picture from Marcel's PhD thesis, which describes the idea that we have some built-in access methods to search for the data, and after implementing GiST, we have trees that can be described by data types. So we kind of have extensions of extensions, and this idea of extreme extensibility was very natural to Postgres, because Postgres was designed to be extensible, and Stonebreaker was thinking a lot about implementing access methods. That's why GiST was brought into Postgres. Initially it was brought by Oleg Bartunov and Theodor Sigaev. It's mentioned in our official documentation, which have a reference to their website, which describes many core ideas in depth. And I just today checked again that all the ideas are still relevant to these days. No, most of ideas, except some recovery things changed, but later on this. GiST can be used to search by different criteria, but most common usage of GiST is PostGIS. PostGIS is a geoinformation system. The idea is that we can use database to store information about maps. And when you use GiST for indexing PostGIS, it is describing map objects with bounding boxes and insert it into something like R3 which is based on GiST. Actually, at the beginning, GiST was called R3, but later it was superseded by just GiST. And now, fast forward to our days. What recent technologies did we gain in new releases? And actually, in fact, almost any major Postgres release have a new features in GiST. That's in fact amazing because the technology is like invented 30 years ago and still is actively developed by the community. One of the oldest advancement in my list is a predicate locking. That is Google Summer of Code project when student added predicate locks. What's the purpose of this predicate locking? When you are using serializable transaction isolation with GiST predicate locking, you can have a much less serialization conflicts, and thus allowing the database to be more performant in this quite strict serialization, quite strict isolation level. And it's amazing that such difficult technology was implemented by student, and actually patch was committed with just some slight modifications by reviewers and committers. But let's move on. In Postgres 12, we got covering indexes. That's a way to tell the database that we can use some columns as a key columns, which then can be used in queries as predicates. And these columns must have operator classes to be special operator classes to be indexable, and even more special operator classes to be invocable from index-only scan. But this commit allows user to include columns that do not have a special operator class for GiST, and these columns can be used by index-only scan. This patch was developed by me, and it was committed with a lot of modifications by Alexander Korotkov. It's quite interesting because in Postgres 11, as far as I understand, Alexander committed covering indexes for B-trees. Thus, he was extending his, not committed, he wasn't committer of the principal committer of the patch with B-tree, but he committed, he worked a lot on covering B-trees, and then when he became committer, he committed these covering indexes into Postgres 12. And actually, difficult part of technology starts only when the patch is committed, because then some bugs are found. I won't mention bugs found by Tom Lane, but in every single patch that I am presenting here, Tom fixed at least one bug, and that's super interesting that he is capable of like fixing a lot of different stuff, and many thanks to Tom for doing this work. But let's talk about some bugs. For example, later, after 2 years, Pavel Borisov found bugs in included columns. That there was incompatibility of buffer and builds that existed was used at that time, and included columns, and that kind of bugs happened from time to time, and it was fixed. This feature covering GiST indexes still can be improved. For example, if the same column is used as a key column and as a included column, planner will not issue index-only scan if operator class of column 1 does not support attributive fetching, because it thinks that it could be in key. And for example, this is a problem for PostGIS because PostGIS have a bounding box in a key. Also, the same problem goes with the text search when we are including text column into trigram index. We still cannot use index-only scan on this covering index, and this fix is yet to be done. But let's go further. In Postgres 13, we got a faster vacuum. We got actually changes in vacuum in two different ways. First is that we got physically ordered scan. Before this feature, GiST tree was traversed in depth first scan and was vacuumed there. And because the tree was not always ordered, was not always physically ordered, in many cases it was very slow on hard drives and was not very read-ahead capable on SSD drives. But also the problem was that GiST vacuum was not actually able to reuse deleted pages. If the page was completely empty, it still had to occupy the place and could not be reused for other parts of tree. But starting from Postgres 13, these deleted pages can be reused to accommodate another part of key space. The interesting part of this work that it started as a Google Summer of Code student project by Konstantin Kuznetsov. He was working on this patch for quite a long time after finishing Google Summer of Code, which was basically summer, and it's not enough for many features in Postgres. After 2 years, I started to help Konstantin at some point to cover the work completely. Here is a Konstantin on a seminar discussing this technology with other hackers. I think it was in Postgres professional office or something like that. And in Postgres 13, it was finally committed by Heikki. I'm like marked in the commit message as an author, but in fact, Heikki completely rewrote my patch. not from the scratch, but Heikki used a lot of B3 code, which in fact made GiST much better. GiST code of vacuuming much better. Here is a review from PGCon hackers mailing list. Jeff Janes is writing that this change is a transformational change. The GiST vacuuming now is on order of magnitude faster than it was before Postgres 13. Jeff tried this technology long before release, right after the commit, and I was really happy to read this message in the list. Also, with GiST vacuum, we committed a new library integer set because we could not reuse bitmap sets. There is a like slight interface problem in bitmap sets, that is regular Postgres bitmap sets are containing signed integers, like set of signed integers. But we had to have a bitmap set of blocks that are deleted, and block number is unsigned, That's why we needed a new structure. And this integer set is not only capable of 64-bit integers, it's also much more efficient in terms of memory usage when the bitmap set is in fact sparse. As usual, there were a lot of different bugs that were fixed later. Many of these bugs were fixed by Hiki immediately after commit, but some were popping around here and there. I was monitoring it. Here is an example of a bug found recently, like a month ago, by Alexandra Lachin. There is a member of a PostGIS community. His name is Dorofei Parliskovsky, and he's so active about developing GiST and doing it faster that he deserves a special mention, despite the fact that he never wrote any patch for Postgres himself. He have done a lot to organize people. First time we interacted with Dorofei when he brought to PostGIS very tricky penalty function for geometry support. This penalty function allowed PostGIS to build a super effective indexes in terms of search performance, but this penalty function took quite a big amount of time to be computed. We were working together to make it produce better assembly instruction set. But yet in this project, we decided that we must do GiST index build faster, somehow faster. Initially, Dorofei started to ask Nikita Glukhov to do something with slow index creation. And in fact, we had a buffered build, like bulk load of GiST, but it was not super performant. And building B-tree index is like 10 times, from 10 to 20 times faster than building GiST index was. That's why Nikita Glukhov prototyped copy-pasting code from B-tree to GiST, and it really showed that this proof of concept showed that we can improve B-tree index creation time by order of magnitude. But Nikita, for some reason, decided that it's just prototype and did not pursue this idea. You see a screenshot from his commit log in 2019. So I took over the project and continued from his patches, tried to do something more committable, something that is easier to review, and the code could be like easier to grasp and easier to find bugs. The project ended up in adding another function for GiST API, now operator class supporting one more function, which is called sort support. Basic idea is, again, as usual, copied from B-tree, because B-tree gets a lot of attention from optimization standpoint. And we took this sort support function, and now if the operator class is supplying this support function, when we are building GiST, we are sorting data according to Hilbert curve. This Hilbert curve is built using comparison function that is provided by sort support function of operator class. So we are able to sort the data in some order that should preserve spatial locality. And then we fill the pages exactly the same way as B-tree does. Here are some benchmarks. If we are using on roads data from OpenStreetMaps, you can see here that with sort support, we create index 10 times faster, almost 10 times faster, 8 or 9 times faster. And this index is almost twice smaller, but the search performance is twice bigger. So we are getting faster index, but this index is not that effective as it was. The feature was committed by Heikelin and Kangas. It's available in Postgres 14. As usual, we got some extra benefits with committing this stuff. We got page inspect functions for GiST indexes. As usual, we had some bugs. Here is a simple bug found and fixed by Melanie Plageman. So starting from Postgres 14, that was a default way to create index, but indexes became slightly less efficient on read queries. PostGIS 3.2 is using this technology for two-dimensional geometry. After committing this feature, Oleg Bartunov created his presentation, new version of his presentation about key nearest neighbor search. And there was a very interesting and catchy thing that on many queries, that ordered sorted GiST index is okay. It works. It works almost the same way. But at some points in a data set, it is like order of magnitude slower. Here you can see that Oleg used the world's map to benchmark in a KNN search in different places. And here you can see that searches near west coast of North America and near India are significantly slower. And in fact, these areas are areas of interest. That's why he convinced me and other hackers that we should improve something in our sorting build. And we started to investigate what's the problem. First of all, sorting build fixed fill factor. This is a relation option of index when it's created. And previous versions of GiST were ignoring fill factor and usually created indexes with fill factor 66 to 70%. Starting from sorting build in Postgres 14, we were creating exactly requested fill factor. And the second fun fact that we uncovered is that the less fixed fill factor we have, the more performant searches are in select queries. But we could not just start discarding fill factor and ignoring fill factor. And we were looking for other ways to improve GiST performance, still maintaining honoring fill factor. What was the problem? Problem was that we were creating quite long needle-like nodes which were overlapping with each other a lot. And in fact, original R3 paper by Anthony Gutman mentions that needle-like nodes are as a result of very poor split function of operator class. Split function, like Anthony Gutman was not working in these terms, but the problem was a split function. But sorting build is not using nor split function, neither penalty function from GiST. And we devised a new algorithm that was still using pre-sorted data, but it is now accumulating many pages at one buffer, and then applying split function recursively until it is satisfied with resulting fill factor. So we are honoring fill factor and using split to optimize leaf nodes overlap. Here you see some benchmarks that we got. In Postgres 15, you can see that create index is again slower than it was in Postgres 14. But then searches are much faster. For example, self-join is faster like 2 times or so. And what's more important that each edge cases when the search was not operating well enough were fixed. There is a small nuance that algorithm that we devised is not described in any scientific paper, and the only source of truth now is PGCon hackers mailing list. And the other problem is that we have a magic constant, like number of pages of pre-buff for pre-sorting that is used, and we found no differences between any numbers more than 4. Thus, we hard-coded number of pages equals to 4. But maybe there are some edge cases, I'm still not sure. It looks like it's working well enough, but some doubts are still there. This new GiST build is available since PG15. It's default in PostGIS 3.3. Principal developer of that version of build was Alexander Kolenik from Contour, and Sergey Shulbakov also helped. We did not uncover any major bugs there yet, but maybe I'm monitoring PGCon hackers for PGCon bugs for new reports. That's what we have now, but what is to do? This new sorting build lacks support from GiST B3 types. I was working on this patch for quite a long time, and that there was a point when Heike even committed this patch. After committing, we found some failures on build machines, on build farm, and this patch was reverted. At some point, Christoph Hayes took over the patch, and he's now working on that patch, but there is some work to be done yet. Also, there is a functionality in access method check verification for GiST and for Gin, and GiST version is in much better shape. But there is still some bugs uncovered by reviewers. Alexander Lachin reported one bug that I hadn't fixed yet. And also there are some ideas that worth implementing, but they are not there yet, even in a form of Postgres patches. For example, spatial join was implemented by Alexander Karankov in PGSphere extension, but it's no near ready to be in core. Another option is to improve GiST API to support more performant spatial indexing, like RR*3 index. There is a good scientific paper which is now 10 years old, but we still do not have a Postgres implementation of this tree, and it's believed to be most performant spatial access method. I was working for some time on intra-page indexing to match GiST performance with B3 performance. B3 for data types with natural sort order is much more efficient in searches. To cover this efficiency gap, we must give some intra-page search method, which is equivalent to binary search that is used in B3. But so far we don't have it in any like simple enough to be committable way. Another idea that I have is to move GiST to contrib model, as it would further improve extensibility. But to do so, we need some improvement in generic write-ahead logging. That was the idea that I mostly that I hear most of the time. Once again, as you saw, that all these technologies are developed by our community, and thank you for being part of this community. Thank you for working on PostGIS, and also special thanks to Chris Travers and PGCon team to help me to do these virtual presentations. Thank you so much. If you have any questions, I'd be happy to answer them.
If we can just have a concept module which has its own visual factor.
So your question was, in Postgres 15, because of the ability to log your own redo managers, why would you need improvements to the generic write-ahead log stuff?
To move GiST into contrib model, we would need too much performance of specialized resource manager. Actually, now, if we are doing like logging of changed generic indexed page, we have to compare changes of old page and new page. This is, as far as I know, this is not so performant. But maybe I'm wrong here.
Resource manager. I'm not sure what it's called, but RMGR for GIS is currently in core, because you can totally pull that out into a custom into the concept module, because you can register your custom extension-based redo manager right now.
So his point was that that basically the pieces here are all in core, but they could possibly be moved into contrib also in the GiST module and registered there. At least that's what he was thinking.
Sorry, I didn't get it. Get the idea. If you can you please ping me with information about this? If we can like work on this, it would be great.
He says he'll send the mail.
Thank you.
Another question? I don't see any other questions.
Thank you so much for your questions and for your time. I hope next year we will see. I will see you in person. Thank you. Have a great day and a great conference. Bye.
All right.